Okay, so let's use the leading term test to determine a function's end behavior. Okay, so let's look at the first one, -7 x to the 5th plus 2x to the 3rd plus 7x plus 5. All right, so we want to look at the highest power. All right, so we call that our leading power. All right, so the biggest power we have is 5. And is 5 an even or odd number? It's an odd number. Okay, so that's going to tell us we're going to be in this category. Our power is odd. All right, then we want our leading coefficient. Okay, so our leading coefficient that goes with our big power is -7. And that is a negative number. So that tells us we're in this category. So that means for the end behavior of our function, it's going to rise left and fall right. So what does that mean? On the left side, well, that's when we get closer and closer, if we look at a number line, to -infinity. All right, so as x goes to -infinity, our function is going to go down to infinity. That's what it means to, sorry, over here. Our function is going to go up to infinity. That's what it means to rise left. So as we go to the left side, so x goes to -infinity, our function gets higher and higher, so our function goes to infinity. And then for fall right, well, what happens on the right side of the number line? We get positive infinity. X goes to positive infinity. We're going to fall, so we're going to go down. So that means our f of x is going to go to -infinity. So that is our end behavior of our function. All right, let's do another one. So this one looks factored. It's a factored function. Okay, it's still a polynomial. So 1/4 x, 2x minus 3 cubed, x plus 4 squared. How are we going to figure out the highest power here and the biggest coefficient? Well, we can look at what it would be like to multiply this all out. Okay, so we're going to end up with 3x here, because this is cubed, and 2x's here, and also this 1x. And I'll show you how we can figure that out. All right, so what I'm going to do is expand this. So I'm going to expand the third, and I'm going to expand the square. So 1/4 x. That means I need to multiply this 3 times. And then this 2 times. All right, so we're not going to multiply all of this stuff out. That would take forever. We only care about our leading term, so our biggest power. All right, so how are we going to get the biggest power? Well, that's if we multiply this x by every one of these first terms. All right, because that would be the first step, right? Multiplying x by all of the first terms. Okay, and so that will give us, so let's start with the coefficients. 1/4 times 2 times 2 times 2 times 1 times 1. So that's all of the coefficients of these x we're multiplying. And then let's see how many x's we have. 1, 2, 3, 4, 5, 6. X to the 6th plus ... right, because there would be more. But we only care about the first term. All right, so when we multiply this out, we should get 2x to the 6th plus the rest. Okay, and we only did the first term because that's all we care about right now to determine the function's end behavior. All right, so our leading power is 6, and that's an even number. So that tells us exactly what category we're in. They're either both going to go up or both going to go down. So to determine what it's going to be, we look at our leading coefficient. That's 2. That's a positive number. All right, so positive tells us they're both going to go up. So it's going to rise left and it's going to rise right. All right, so on the left side, thinking about a number line, x goes to negative infinity. Our function is going to rise, so our function is going to go to positive infinity. And then as x goes to positive infinity, so on the right side, our function is also going to go to positive infinity. All right, so that's how we determine the functions in behavior, and all of this is going to come together to help us graph these. All right, so the next thing we need to identify to be able to graph a polynomial is the zeros and figure out the multiplicities of those zeros. Okay, so let's talk about multiplicities and x-intercepts. If f is a polynomial, then the values of x for which our function is 0, so basically setting our function equal to 0, that gives us the zeros, or you could call them roots, or you could call them solutions of our function. All right, so these are also known as x-intercepts. So we've learned this before. How do you find an x-intercept? You set y equal to 0. So we're going to set our function equal to 0, and that's going to give us the zeros, or the roots, or the solutions of our polynomial. Okay, and so if we find that root or that 0 and call it r, if it's of even multiplicity, and I'll explain what that means, then the graph touches the x-axis and turns around at r, our root. And if our root, or a 0, is of odd multiplicity, then the graph crosses the x-axis. And so regardless of whether the multiplicity of a 0 is even or odd, the graph tends to flatten out near the 0. So that's just a little extra. But we're going to talk about what it means to have even multiplicity and odd multiplicity. All right, so here's what we're going to do. We are going to find the zeros of each one of our polynomials to determine the multiplicity and determine if our graph is going to cross the x-axis or touch the x-axis and turn around at those zeros. All right, so remember, to find the 0, we just want to set our function equal to 0. Okay. And so now we have a factor form, which is great because we have a bunch of things multiplied by each other to give us 0. That means this one could equal 0, or this one could equal 0. All right, so here we get x is negative 3. Here we get x is 7. So these are our two zeros. This is where our graph is 0. Negative 3 and 7. Those are the zeros of our graph. All right, now let's talk about multiplicity. So we need to talk about each 0 separately. All right, so at x equals negative 3, that's one of our zeros, we can talk about the multiplicity. So that's basically how many times do we have this 0 of negative 3? Well, it's based on how many factors we have right here, right? There's only one. The multiplicity is 1. And 1 is an odd number. All right, and so by our definition, if our multiplicity is odd, then the graph crosses the x-axis at our 0. All right, so this means that our graph crosses the x-axis at x equals negative 3 because the multiplicity was odd. So at x equals negative 3, our graph is going to cross the x-axis. All right, our other 0 was x equals 7. So how many times will we get will 7 give us a 0? Well, twice up here. Here's our power. The multiplicity is 2, which is an even number. So that tells us our graph does not cross the x-axis, however, it touches the x-axis and then turns around. Okay. All right, so this is our information about what our function does at the zeros, and we'll do another example.